Hi, in this video, we will discuss the dependency inversion principle. Let's get started with the definition. High-level modules should not depend on low-level modules. Both should depend on abstractions, and abstractions should not depend on details. Details should depend on abstraction. Let's try to understand the first part of the definition. In software engineering, we usually split the application architecture in terms of layers. For example, the UI layer, the controller layer, or the DAO layer, and so on. In this paradigm, high-level module depends on low-level module to achieve a certain set of functionality. What this part says is that your high-level module should not depend on low-level modules directly. And this basically translates to the reference code I have shown in the picture. Well, if you see in the picture, I am creating a direct dependency on the low level module by instantiating a concrete class for it. Now, what the first part of the definition says is that you don't create new objects for low level concrete classes in your high level classes. Doing this ties your high level class with their low level counterparts, and any change in the low level module starts affecting the high level module. Let's try to understand why this is a problem from a physical perspective, which can give you the same analogy. Let's say your high level module is your operating system and your low level module is the random access memory. Do you think that any change in the RAM should affect how your operating system works? You don't, right? And this works because your operating system is not dependent directly on the exact RAM you're using, but rather it depends on an abstraction, which is the kernel. Just imagine what a nightmarish scenario would that be when you change your RAM and your operating system starts to behave differently. That is the exact same scenario which will happen if you start directly tying your low level module with your high level module. Similarly, for all software projects which are divided into different high level and low level layers, make sure that there is no tight dependency between them, as I mentioned. Usually, higher level modules are those modules which are close to the end user, and lower level modules are very far from the end user. And this is a good way to segregate between the different levels of your code. So instead of depending on the concrete implementation of the class, depend on the abstraction, which are hiding the implementation from the high level modules and only exposing the contract. This process is called inverting the dependency. In the previous slide, you were directly depending on the concrete implementation, and now you are depending on the abstraction instead. That's inverting your dependency. If you look at the example code, it creates an interface I low level module, which is implemented by your low level module. This interface is your abstraction, and if you see in high level module, we are auto wiring this abstraction instead of the concrete low level module. Let's talk about the second part of the definition. Abstraction should not depend on details. Details should depend on abstraction. These are the following heuristics which comprise this part. There should be no variable which holds a pointer reference to a concrete class. No class should derive from a concrete class, and no method should override an implemented method in the base class. Well, I find these rules a little funny because how else you will be able to code if you're not even allowed to do the basic things, because inserting an abstraction on every call is madness. According to me, you should have good abstraction between layers and critical parts of your code. If you start avoiding the new keyword at all point of time, things might become nightmares too soon. So for this, the exception is if the concrete class does not change at all and is completely local to the context, there is no harm to depend on it. So where exactly can you apply dependency inversion? Basically, between any two classes who are calling each other. But again, just because you can doesn't mean you should. What I would suggest is that you identify your layers well and isolate them with each other using dependency inversion. And let me show you how. So here I am considering a very small example for dependency inversion scenario. We have a button class which is polling for user events, and whenever there is a trigger, it invokes lamp's turn off or turn on method. So what are the problems with the current example? Button directly depends on the lamp. So there's a clear DIP violation as it should depend on an interface. If there are any changes in the lamp, the button is directly affected, and your button cannot be used to turn off or turn on something else which provides a similar functionality since it is heavily coupled with the lamp. Let's try to add an abstraction and see how this helps. So, first of all, we have added a button server interface which LAMP is implementing to give implementation for the turn on and turn off method. And what button server is doing is acting as an abstraction over the LAMP. So instead of calling the LAMP directly, now your button is talking to the button server, which in turn talks to the LAMP. So we have added this abstraction and we have fixed the DIP violation. And it ensures that any change in the lamp does not affect the button as long as the turn off and turn on method are working as expected. Also, now if you see, you can easily replace the implementing class for the button server with a motor or a fan or anything which has a similar kind of functionality. And this way, your button class is not directly or tightly coupled to the lamp as it could be reused to turn on and turn off several different objects. And this is the flexibility what dependency inversion principle is trying to give you. It is trying to isolate your higher level modules and lower level modules with each other so that they don't depend on each other in such a way that any change in any of the module affects the module which is above it, which is the button module in this case. Now, if you look at the name for the abstraction we have provided here, it's called button server. Now, just by looking at the name, it feels like this abstraction could only be used with a button, but that's not the case, right? It could be used with anything which has a turn on or turn off functionality. So why name it button server? So let's go and fix this. We will be changing this to a switchable device. And now your abstraction in the name way is also not coupled with a button, which means the abstraction does not depend on the detail. That's it for the dependency inversion principle. I hope you have understood it and you will use it wisely. See you later.